there's no wall. OpenAI has just revealed O3, showing tremendous improvements over the just released O1 model, silencing all the rumors that AI improvement has hit a wall. Let's dig right in.
Good morning. We have an exciting one for you today. We started this 12-day event 12 days ago with the launch of O1, our first reasoning model. It's been amazing to see what people are doing with that and very gratifying to hear how much people like it. We view this as sort of the beginning of the next phase of AI, where you can use these models to do increasingly complex tasks that require a lot of reasoning. And so for the last day of this event, we thought it would be fun to go from one frontier model to our next frontier model. Today, we're going to talk about that next frontier model, which you would think logically maybe should be called O2, but out of respect to our friends at Telefonica, and in the grand tradition of OpenAI being really, truly bad at names, it's going to be called O3. Actually, we're not going to we're going to announce two models today, O3 and O3 Mini. O3 is a very, very smart model. O3 Mini is an incredibly smart model, but really good at performance and cost. So to get the bad news out of the way first, we're not going to publicly launch these today. The good news is we're going to make them available for public safety testing starting today. You can apply, and we'll talk about that later. We've taken safety testing seriously as our models get more and more capable. And at this new level of capability, we want to try adding a new part of our safety testing procedure, which is to allow public access for researchers that want to help us test.
So there you have it, a new frontier model and a cheaper version, O3 Mini. But now you're probably wondering, when will this be released? Let me give Sam Altman the answer to that question.
O3 Mini and O3. Apply please if you'd like for safety testing to help us test these models as an additional step. We plan to launch O3 Mini around the end of January and full O3 shortly after that. But that will, the more people can help us safety test, the more we can make sure we hit that.
So the release is scheduled for at the end of January. Although this is just the O3 Mini model, and based on previous releases, the new frontier model O3 will probably take some time. Now to the point we all have been waiting for. How does O3 compare to the recently released O1?
And I want to talk a little bit about O3's capabilities. Now, O3 is a really strong model at very hard technical benchmarks. And I want to start with coding benchmarks, if you could bring those up. So on software style benchmarks, we have SweetBench Verified, which is a benchmark consisting of real-world software tasks. We're seeing that O3 performs at about 71.7% accuracy, which is over 20% better than our O1 models. Now, this really signifies that we're really climbing the frontier of utility as well. On competition code, we see that O1 achieves an ELO on this contest coding site called Codeforce of about 1891. At our most aggressive high test time compute settings, we're able to achieve almost like a 27 ELO here.
So Mark was a competitive programmer, actually still coaches competitive programming. Very, very good. What is your?
I think my best at a comparable site was about 2,500.
That's tough.
Well, I will say, our chief scientist, this is also better than our chief scientist Jakob's score.
I think there's one guy at OpenAI who's still like a 3,000 something.
Yeah,
gets a few more months to enjoy.
Hopefully we have a couple of months to enjoy there.
Sorry to interrupt, but did you notice what they just stated? It was stated as a joke, but it's actually quite serious. They stated that one of their employees, who scored 3000 ELO on the Codeforce's benchmark, will only have a few more months to enjoy being better than one of OpenAI's upcoming models. That's quite interesting. Well, enough talking, back to the video.
Great.
I mean, this model is incredible at programming.
Yeah, and not just programming, but also mathematics. So we see that on competition math benchmarks, just like competitive programming, we achieve very, very strong scores. So O3 gets about 96.7% accuracy versus an O1 performance of 83.3% on the AMI.
What's your best AMI score?
I did get a perfect score once on this, so I'm safe. But
Congratulations.
Really what this signifies is that O3 often just misses one question whenever we test it on this very hard feeder exam for the USA Mathematical Olympiad. There's another very tough benchmark, which is called GPQA Diamond. And this measures the model's performance on PhD level science questions. Here we get another state-of-the-art number, 87.7%, which is about 10% better than our O1 performance, which was at 78%. Just to put this in perspective, if you take an expert PhD, they typically get about 70% in kind of their field of strength here. So one thing that you might notice, from some of these benchmarks is that we're reaching saturation for a lot of them, or nearing saturation. So the last year has really highlighted the need for really harder benchmarks to accurately assess where our frontier models lie. And I think a couple have emerged as fairly promising over the last months. One in particular I want to call out is OpenAI's Frontier Math benchmark. Now, you can see the scores look a lot lower than they did for the previous benchmarks we showed. And this is because this is considered today the toughest mathematical benchmark out there. This is a data set that consists of novel, unpublished, and also very hard to
These
guess.
are extremely hard.
Yeah, very, very hard problems. Even Turnstile says, it would take professional mathematicians hours or even days to solve one of these problems. And today, all offerings out there have less than 2% accuracy on this benchmark. And we're seeing with O3, in aggressive test time settings, we're able to get over 25%. In addition to OpenAI's Frontier Math benchmark, we have one more surprise for you guys. So I want to talk about the ARC benchmark at this point.
Today, I'm very excited to say that O3 has scored a new state-of-the-art score that we have verified. On low compute for O3, it has scored 75.7 on ARC AGI's semi-private holdout set. Now, this is extremely impressive because this is within the compute requirements that we have for our public leaderboard, and this is the new #1 entry on ARC AGI Pub. So congratulations to that.
Thank you so much. Yeah.
Now, as a capabilities demonstration, when we ask O3 to think longer and we actually ramp up to high compute, O3 was able to score 85.7% on the same hidden holdout set. This is especially important.
87.5.
Sorry, 87.5, yes. This is especially important because human performance is comparable at 85% threshold. So being above this is a major milestone. And we have never tested a system that has done this or any model that has done this beforehand. So this is new territory in the ARC AGI world.
So now, together with O3, I'm very happy to tell you more about O3 Mini, which is a brand new model in the O3 family that truly defines a new cost-efficient reasoning frontier. With the release of adaptive thinking time in the API a couple of days ago, for O3 Mini, we'll support 3 different options: low, medium, and high reasoning effort. So the users can freely adjust the thinking time based on their different use cases. So for example, for some, we may want the model to think longer for more complicated problems and think shorter with simpler ones. With that, I'm happy to show the first set of evals of O3 Mini. So on the left-hand side, we show the coding evals. So it's code versus ELO, which measures how good a programmer is, and the higher is better. So as we can see on the plot, with more thinking time, O3 Mini is able to have increasing ELO, all outperforming O1 Mini. And with median thinking time, it's able to measure even better than O1.
Yeah, so it's for an order of magnitude more speed and cost, we can deliver the same code performance on this eval.
Or even better
or even
experience, right? So although it's the O3 Mini high is still a couple hundred points away from Mark, it's not far. It's better than me, probably.
But just an incredible sort of cost to performance gain over what we've been able to offer with O1, and we think people will really love this.
Yeah, I hope so. So on the right-hand plot, we show the estimated cost versus code versus ELO trade-off. So it's pretty clear that O3 Mini defines a new cost-efficient reasoning frontier on coding. So it's achieved better performance, comparable better performance than O1 with a fraction of cost.
Amazing.
So we show on this plot with on this AMI 2024 dataset, O3 Mini Low achieves comparable performance with O1 Mini, and O3 Mini Medium achieves comparable better performance than O1 if we check the solid bar, which are pass of ones. And we can further push the performance with O3 Mini High, right? And on the right-hand side plot, when we measure the latency on this anonymized O1 preview traffic, we show that O3 Mini Low drastically reduced the latency of O1 Mini, right? Almost achieving comparable latency with GPT-4o. Where it's under a second, so probably it's instant response. And O3 Mini Medium is half the latency of O1. And here's another set of evals that I'm even more excited to show you guys is API features, right? We get a lot of requests from our developer communities to support like function calling, structured outputs, developer messages on all mini series models. And here, O3 mini will support all these features, same as O1. And notably, it achieves like comparable, better performance than for O on most of the evals, providing a more cost-effective solution to our developers.
Cool.
And if we actually unveil the true GPQA diamond performance that I ran a couple of days ago, it actually also means though is actually 62%, right? We basically ask the model to evaluate itself.
Yeah.
Right. Next time we should totally just ask the model to automatically do the evaluation instead of us doing it. Yeah. So with that, that's it for O3 Mini, and I hope our user can have a much better user experience early next year.
Fantastic work.
Yeah. Thank you
really
so much.
great work on you.
Thank you.
This technique, called deliberative alignment, allows us to take a safety spec, allows the model to reason over a prompt, and also just tell, is this a safe prompt or not? Oftentimes within the reasoning, it will just uncover that, hey, this user is trying to trick me, or they're expressing this kind of intent that's hidden. So even if you kind of try to cipher your prompts, oftentimes the reasoning will break that. And the primary result you see is in this figure that's shown over here. We have our performance on a rejection benchmark on the x-axis and on over refusals on the y-axis. And here to the right is better. So this is our ability to accurately tell when we should reject something, also our ability to tell when we should refuse something. And typically you think of these two metrics as having some sort of trade-off.
It's really hard to do well on both
Yeah,
at the same time.
it is really hard to do, yeah. But it seems with deliberative alignment that we can get these two green points on the top right, whereas the previous models, the red and blue points, signify the performance of our previous models. So we're really starting to leverage leverage reasoning to get better safety performance.
Yeah, I think this is a really great result of safety.
Yeah, fantastic.
Okay, so to sum this up,
I will end this video by saying this new reveal from OpenAI goes to show that the progression of AI is not slowing down. Let this be a guide for us as well, to never back down, even when so many people are doubting us. And remember, curiosity cured the cat. Stay curious. Until next time.
Thank you for watching. Don't forget to subscribe if you liked the video. Did you subscribe yet? I'm waiting. Thank you for subscribing.